All right, here are the last two examples on the handout. So let's go ahead and find all the zeros and provide the factorization for both of these. So here, the leading coefficient is 2 and the constant is 4. So the possible values of P are the factors of 4, and the possible values of Q are 1 and 2. All right. I'm going to go ahead and write my P over Q list this time just to model it a couple more times here. So I'm going to put all the P values over 1 for the first row. I'm going to put all the P values over 2 for the second row. So we've got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1. Right? On the second row, I'm going to put all the P values over 2. So I have plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 4 over 2. Right? So then I'm going to mark off the ones that reduce because they're duplicates. 2 over 2 is just 1. 4 over 2 is just 2. Right? Remember, the ones over 1 are not duplicates. We really need to keep those. So my possible rational zeros, 1, 2, 3, 4, doubled is 8. I have 8 possible rational zeros. Now these rational zeros are whole numbers and half and negative half. I think those are easy enough to spot on the graph. So to figure out which ones work, I'm just going to look at the graph of this function here. So y equals, let's put the function in. And double check it real quick. All right, looks good. So I'm going to graph. Now keep in mind we have a 4th degree polynomial, so we would really like to see it touch across 4 times. If it doesn't touch across 4 times, then we have to do synthetic division. But what is that number? That is not negative 4. It's negative 2. Is that negative 1/2? Let me look at the table. Negative 1/2 is a 0. Why doesn't that look like 4 to me? I mean, like, am I going crazy? I might be. 4/6. Yeah, that is so strange. What is going on? Is this negative 2? Two x to the 4th plus 15x cubed plus 31x squared plus 20x plus 4. We should not be having a 0 at negative 4 point something. All right, bear with me, guys. One, 2, 3. Alright, I have no alternative here but to write down the zeros that I know for sure and divide them out. -2 and -1/2. Alright, you guys agree? -2 worked, -1/2. Not only did -1/2 work, but I believe it to work twice. This might be where I'm wrong, okay? This might come down and intersect it instead of bounce. But so I'm going to try and divide -1/2 twice, but it might not work, okay? So let's do the synthetic division. The reason why I don't think -1/2 works twice is because this 0 is not a whole number, okay? So if we had 3 of the 4 zeros, the other 0 would have to be in this list, and it's not. So I'm thinking we have 2 zeros really super close together there, and we're going to have to use the quadratic formula to find them. All right, so let me go ahead and divide by -2 first. 4, 3, 2, 1, 0, 2, 15, 31, 24. All right, add down, multiply, in the next adjacent spot, add down, multiply, put in the next adjacent spot, add down, multiply, put in the next adjacent spot, add down. Did I do something wrong? Yep. I did something wrong. You guys see it? This one should have been 11. All right. It is late. Your teacher is tired. All right, let's try again. All right. I knew I wasn't going to get a 0 remainder, so I knew I did something wrong. This is what's going to happen. Okay. Hopefully, this is a learning moment, right, to see what happens when you make a mistake. Yeah, start over. All right, add down, multiply. 15 minus 4 is not 9. 15 minus 4 is 11. All right, multiply, add down, multiply, add down, multiply, add down. Much better. All right, so now I'm going to divide the answer by -1/2. I think if I was smart, I would erase this video and start over, but I don't want to do that. Okay, let's go ahead and add down. Multiply. -1/2 times 2 is -1. Add down. -1/2 times 10 is -5. Add down. -1/2 times 4 is -2. Add down. All right, so I know these two work, right? And here is my quotient. And I know I can, do the factors at this point, but I'm really curious to see if -1/2 is a 0 again, right? To see if it truly touched the x-axis. So let's add down. -1/2 times 2 is -1. Add down. -1/2 times 9 is -4.5. So see how we don't get a 0 remainder? That means -1/2 does not divide twice, right? So we only have 2 rational zeros here. Yeah, this one is tricky, okay? Because those 2 zeros are so close together, it looked like the graph touched the x-axis, but it actually did not. All right, so for factors, remember, we're not going to use this here, okay? This didn't work. So -2 worked. So we have x plus 2 as a factor. -1/2 worked. So we have x plus 1/2 as a factor. And then the quotient is our other factor. So this is our x squared, x constant. So we have 2x squared plus 10x plus 4. Right? So notice, again, we can factor a 2 out of this factor, And so if our factors factor, we have to keep going. But the 2 we factor out of here is what's going to get multiplied times the one that has our fraction. Okay, so if I take a 2 out of this one, I'm left with x squared plus 5x plus 2. And that's the 2 that I want to distribute here. So that's going to get me 2x plus 1. And then I have the x plus 2. All right, so here it is factored. Okay, and this is completely factored because none of my factors factor any further. But I still don't have all my zeros, right? I only have 2 zeros. The other 2 zeros come from this quadratic. So I'm going to take this quadratic equation. I'm going to set it equal to 0 and solve. Now this one I have to use the quadratic formula. All right, so I'm going to get x equals negative b plus or minus the square root b squared minus 4ac all over 2 times a. So I'm going to get 25 minus 8. So I get square root of 17 over 2 here. Okay, so this is irrational, right? But they're still real. Okay, so if it's asking for the real zeros, you're going to list both of these, right? You're going to list negative 5 plus rad 17 over 2, and you're going to list negative 5 minus rad 17 over 2, right? And I bet you one of these values is really super close to negative 1/2, all right? Let me check it. We're going to get negative 5 plus rad 17 divided by 2, negative 0.438. So that was really close to our negative 1/2 0. Okay. Now if I do the other one, negative 5 minus rad 17 and divide that by 2, there's my negative 4.5 0. Okay, the one that was on the graph that confused the heck out of me at first. All right, so this one had 2 rational zeros, 2 irrational zeros, and that first irrational zero was really close, and it looked like our graph touched the x-axis at negative 1/2, but our synthetic division did not show that. Okay, so we needed to find our zeros using the quadratic formula. All right, that was a good one. That was challenging. All right, let's try the last one. Hopefully it's not as challenging. Or hopefully it is. I don't know how you feel. Here we go. Let's do our P over Q list. Okay, so P, 1, 2, 3, 6. Q, 1, 2, 4, 8. All right, so plus or minus P over Q. I'm going to put all these over 1 on the first row, all the P values over 2 for the second row, so on and so forth. 1 over 1, 2 over 1, 3 over 1, 6 over 1. Then I'm going to put them all over 2. And then I'm going to put them all over 3. And then I'm going to put them all over, oh gosh, I am really tired. All right, the Q values need to be on the bottom, the P values need to be on top. So I shouldn't have put them over 3, I should have put them over 4. All right, and then I need to put all the P values over 8. All right. Now, these have duplicates in them, so I'm going to cross off my duplicates. Actually, let me make sure. Do I have only P values on top? 2, 3, 6. 1, 2, 3, 6. And only q values on the bottom. 1, 2, 4, 8. Okay. Now crossing off the duplicates. 6 over 2 reduces 1/4. 2/4 is 1/2. 3/4, no. 6/4 is 3/2. 1/4. 2/8 is 1/4. 6/8 is 3/4. Right? So if we were to ask the question, how many are in this list? 2, 3, 4, 5, 6, 7, 8, 9, 10. Doubled. Okay, there's 20 possible rational zeros. All right, now we have a 5th degree polynomial. Okay, in a perfect world, we'll find all 5. In an imperfect world, we'll find fewer than 5. But we have to find 3. And the reason why we have to find 3 is because we can only use the quadratic formula if there's 2 zeros left. Right? We have to, at all costs, find 3 of the 5 zeros. So I'm going to type the function into the calculator. I'm going to double check. Looks good. All right, graph. One, 2, 3, 4, 5. All right. So if I count the touching twice, I have 1, 2, 3, 4, 5. Now, this one where it crosses at -2, I think that's a sure thing, okay? I am going to double check it with my table. And I think where it touches here at 1, that's a sure thing. And I think it works twice. Now I am going to double check that. Now the other 2 zeros, right? These may be fractions in this list, or they may be irrational. So to check whether they're fractions in this list, I am going to use the table. Okay, so table, I'm plug -2 in there and 1 in there, just to show that they are zeros. Okay, so the fractions, I'm going to plug 1/2, -1/2, 3/2, -3/2, 1/4, -1/4, 3/4, -3/4. Oh, did you see that 3/4? Gave us a 0. Okay, so 3/4 works. All right, so if you wanted to find 3/4 on that meta calculator, you need to make your change in table 0.25. All right. But again, I will help you guys out with that tomorrow night if you'd like. All right, so let me just check the other fractions. 1/8, -1/8, 3/8, -3/8. 1, 2, 3, 4. Why? I need 5. 2, 3, 4, 5. 1 of those fractions should have worked. 3/4, right? So let me look at the graph again. it's almost like 7/4. Oh gosh. Is this another one where the 1 doesn't work twice? Son of a sea biscuit. Alright, I think it might be, okay, again, I found 4 rational zeros. So it means the other 0 cannot come from the quadratic formula. Because if I were to do the quadratic formula, I would get 2 more zeros. And that would make this have 6 zeros. So it tells me that one of my zeros is wrong. Right? I know 1 works twice, but it might not work a second time. Okay, so now I have 3 zeros. There's 2 more left. So all 3 of these should give me 0 remainder because the calculator tells me it's giving me a 0 remainder. I wasn't sure whether 1 worked twice, okay, just like I wasn't sure before, but now I know it's not going to work twice because I need only 5 zeros. So if I have these 3 zeros plus 2 from the quadratic, that's going to add up to my 5. So again, I am going to do synthetic division by these zeros in this order. -2, then 1, then 3/4. Alright, so first by -2. 8, -14, 5, 4, 3, 2, 1. Okay, I don't need any placeholders. Right. Add down, multiply, add down, multiply, and I am tired. Multiply, add down, multiply, add down, multiply, add down. Okay, so I did get a 0 remainder with a lot of help from the calculator. So I'm going to divide 1 into the answer, okay, into the quotient only. I'm going to leave the remainder off. Adding the 8 down, multiply, add down, multiply, add down, multiply, add down, multiply, add down. Okay, so 1 worked again. All right, so now I'm going to divide by 3/4. All right, bring the 8 down. Multiply times 3/4. So 8 times 3/4 is 6. Add down. -16. Multiply times 3/4. Get -12. Add down. Get 4. Three-fourths times 4 is 3. I should have known that. Add down. Get 0. Okay. So for right now, here are my factors. -2 worked. Let me write that here. So x plus 2 is my factor. 1 worked. X minus 1 is my factor. 3/4 worked. X minus 3/4 is my factor. And then the quotient, I have 8x squared minus 16x plus 4. Right. So I am going to take a 4 out of here. I'm going to factor a 4 out, and I'm going to put it and multiply it times this one. So if I factor a 4 out, I'm left with 2x squared minus 4x plus 1. And that 4 is going to get multiplied times this factor. So this factor is going to become 4x minus 3. Then I have the x minus 1, and then I have the x plus 2. All right, so once again, the graph looking like it touches the x-axis but doesn't really, threw me for a loop for the second time tonight. All right, but here are my factors. This is factored completely because this does not factor any further, right? But if I wanted to find the zeros, all right, I need to set this quadratic equal to 0 and solve. Okay, so I get x equals negative b. So a positive 4 plus or minus the square root. B squared is 16 minus 4 times a times c all over 2a. 16 minus 8 is 8. Okay, so again I have the square root of 8. So if you remember, the square root of 8 is the square root of 4 times the square root of 2, or 2 rad 2. Okay, so I'm going to get 2 plus or minus 2 rad 2 over 2. Alright, so only the 2's on the outside get to reduce. Okay, they're all going to reduce to 1. And so I get 1 plus or minus 1 rad 2. Right, here's my other 2 zeros. So 1 plus rad 2 and 1 minus rad 2. And again, I bet you one of those is super close to 1. 1 plus rad 2 is 2.4. 1 minus rad 2 is negative 0.4. Okay, so the graph, oh, it was, I thought one of these was going to be close to 1. Why is... what? 2.4 and negative 0.4. Equal. All right. Y'all, forgive me. I am super tired, but I'm confident these are the correct answers. All right. We have a 5th degree polynomial, and we found all 5 zeros. I don't know where my brain is right now, but it should like cross at negative 1/2 and 2.5. And it's not negative 2, positive 1. I have no idea what's going on here. I will check it out in the morning. All right, good night, you guys.